Before space was a destination, it was a ceiling. Picture a night with no electric light anywhere, no street lamp, no glow on the horizon from a city you can't see. Just the dark, and a fire, and above it more stars than most of us have ever seen at once. That was the normal sky, for almost everyone who ever lived. We've nearly lost it now. We step outside, glance up for a second and see background. A dark roof over the city. A few stars if the lights allow them. Then a phone buzzes, a porch light clicks on, a car passes, and the sky is gone again. But for nearly all of human history, the sky could not be ignored. It was too large, too regular, too strange. Here's the strange part, though. None of those early people knew what they were looking at. No equations, no orbits, no idea that Earth itself was moving. And somehow, slowly, they learned to read it anyway. That's the thread we're going to follow tonight. Not astronomers first, not telescopes, not even astronomy. We start somewhere quieter, with attention, the slow human habit of looking up long enough for the sky to change. And we'll follow that one habit all the way to a spacecraft passing behind the moon. Nothing here needs to be rushed. Let's begin where they began. Someone, somewhere, noticed that the stars were not scattered at random. Most of them moved together. Hour by hour they drifted across the dark. And season by season something stranger happened. Some patterns vanished for months, then returned. A cluster that disappeared in summer would climb back into the winter sky, right on time. That was not easy to learn. One night could show you beauty. One night could show you movement. But one night could never show you a year. For that, you had to keep looking. Across seasons, across journeys, across births and deaths and storms and hunger and harvest. A single person could learn part of the pattern. A family could remember a little more, and a community, over generations, could slowly build something larger than any one memory. A shared map of the sky. The sky never explained itself. It did something more patient than that. It repeated. And repetition, it turns out, is one of the first teachers human beings ever had. Then there were the lights that broke the rules. 5 of them. Mercury, Venus, Mars, Jupiter, Saturn. To the naked eye, they looked almost like stars. That may be one of the quiet thresholds in human history. The moment the sky stopped being merely above us and became something shared between us. Not because everyone understood it, because everyone could see it. The same stars were visible to many generations. Your ancestors saw Orion, though they may not have called it Orion. They saw the Pleiades, though their stories may have given it another name. They saw the Milky Way long before anyone knew it was made of stars. The names changed, the meanings changed, the lights remained. Of course, we have to be careful with this part of the story. We do not know what the earliest humans felt when they looked up. We do not know whether they were afraid, comforted, amused, indifferent, or deeply moved. They left no diaries, no field notes, no explanations written beside the fire. We have tools, bones, pigments, footprints, burials, cave paintings. From those we infer. We do not possess their inner lives. That uncertainty matters. It keeps the story honest. Still, we can say this much. The sky was too visible, too regular, and too strange to be ignored. It turned above them. It changed with the seasons. Certain lights wandered. Other lights flashed and vanished. The moon kept returning. The sun itself shifted along the horizon. A world like that invites questions, and once questions appear, meaning is never far behind. Because a moving sky is not only something to admire, it is something that asks to be explained. If this kind of slow, curious journey is what you came for, subscribing quietly helps the next one find you. A like does the same. It tells the machinery of YouTube that there is still room for long stories that do not rush the human question. Then came the events that did not fit. Most nights were patterned. The moon had phases. The stars moved in their slow, reliable way. The seasons returned. But sometimes the sky broke its own habits. A solar eclipse is the cleanest example. Daylight begins normally. People are working, walking, eating, speaking. The air may be clear. The sun is where it should be. Then the light thins, not like sunset. Sunset has direction. It has colour. It gives warning. An eclipse is stranger. The brightness drains from the middle of the day. Shadows sharpen. The temperature falls. Birds and insects may change their behaviour. The horizon can glow while the sky above turns dark. For a few minutes, the basic rule of daytime fails. The sun, the most dependable object in human experience, disappears. Now imagine seeing that without prediction. No astronomy, no calendar warning, no one saying, at 11:47 the moon will pass between Earth and the sun, and the shadow will cross this particular region. Just light leaving the world. A total eclipse does not visit the same place often. Many people can live an entire life without seeing one from home. A community could go for generations without experiencing totality, then suddenly stand under the shadow. To us, the explanation is geometry. To them, it was an emergency. And eclipses were not the only interruptions. Comets appeared without belonging to any familiar pattern. A bright tail could stretch across the night for weeks, changing position from evening to evening. Then it would vanish. Meteors crossed the sky in sudden streaks. Sometimes one bright fireball was enough to make everyone look up. During meteor showers, the effect could be far more dramatic. Light after light falling through the dark. Auroras in northern regions turned the sky into moving curtains of green or red. Lightning came down from the clouds with violence, burning trees, splitting rocks, killing animals, starting fires. Each event had a different physical cause. The people seeing them did not know that. What they had was the experience. Something large, bright, high, powerful, and unreachable had changed. Fear was part of it, probably. But fear alone does not explain the human response. If a predator comes from the trees, you do not need a myth in order to react. You run, climb, hide, throw, fight. The danger has a body. It has teeth. It has a direction. The sky is different. You cannot run from an eclipse. You cannot bargain with a comet. You cannot throw a spear at lightning. You cannot tell the aurora to stop moving. When action is impossible, explanation becomes action. That is the important shift. An explanation gives people something to do with their fear. It gives the event a shape. It gives the community a script. Gather here, make noise, pray, wait, watch, remember. A story can turn helplessness into participation. This is why eclipse myths appear in so many cultures. In some ancient Chinese traditions, the sun was being swallowed by a dragon. People beat drums and made noise, not as theatre, but as response. If the sun returned after the noise, the action seemed to have worked. In parts of India, the eclipse was connected to Rahu, a severed being who swallowed the sun or moon. In Norse tradition, wolves chased the sun and moon across the sky. In Vietnam, a frog or toad appears in some versions. In parts of the Americas, jaguars or other powerful animals were imagined as attackers of the sun. The details vary. The structure repeats. Something takes the light. Then the light comes back. It is easy to smile at this now, but the logic is not foolish. It is deeply human. When something vanishes, we ask what took it. When something breaks, we ask who broke it. When something goes wrong, we look for a cause. And very often we look for an agent. Our brains are still built that way. We are pattern-seeking animals. We are cause-seeking animals. We are especially sensitive to agency, because mistaking a branch for a predator is safer than mistaking a predator for a branch. That tendency helped us survive. It also filled the sky with intention. A comet was not simply ice and dust reflecting sunlight. It was a warning, a messenger, a sign before a king died, a war began, a disease spread, or a harvest failed. Lightning was not electrical discharge. It was anger, judgment, force. An eclipse was not an alignment of sun, moon, and earth. It was a struggle, a bite, a theft, a battle. These explanations were wrong in the modern scientific sense. But they did real work. They made events memorable. They turned rare phenomena into repeatable stories. They allowed one generation to tell the next, if this happens, do not collapse into panic. This is what it means, and this is what we do. Not science yet, at least not in the modern sense. But it is not nothing. It is an early form of organising the unknown, and once the unknown is organised, it becomes easier to live beside it. There is another thing worth noticing here. A wrong explanation can still preserve a real observation. If people say, when the dragon eats the sun, beat the drums until it returns, the dragon is imaginary. But the repeated fact underneath is real. The sun does return. The event has a beginning, a middle, and an end. Over time, even mythical explanations can carry careful watching inside them. The sky taught people through repetition, and people stored that repetition in story. This is one of the reasons mythology should not be treated only as fantasy. Myths are not laboratory reports. They do not separate observation from interpretation. They mix memory, fear, moral teaching, politics, landscape, ritual, and weather into a single form. But inside them, very often, there is data. Not clean data, human data, the kind a community can remember. The first explanations of the sky probably grew in that space, somewhere between awe, fear, memory, and practical need. People needed to know when a season would turn. They needed to know whether a strange light had appeared before. They needed to know what elders had said the last time the moon went red or the sun dimmed. Before writing, memory had to carry everything. So events became stories. Stories became rituals. Rituals became traditions. And traditions made the sky feel less empty. That is the vacuum of meaning. Not empty space in the modern astronomical sense, but the inner emptiness produced by an event no one can explain. A hole in understanding. Humans rarely leave that hole open for long. We fill it with a name, a cause, a character, a force, a rule, a god. The name changes across history. The impulse does not. Even now, when something unfamiliar happens, we reach for explanation before we reach for patience. We search, diagnose, blame, model, predict. We may use better tools, better language, better evidence. But the old discomfort is still there. Something has happened. What does it mean? The earlier sky watchers asked that question beneath eclipses, comets, lightning, and falling stars. The answer, for a long time, was not physics. It was sacredness. After the rare events passed, the steady sky remained. Eclipses ended. Comets faded. Lightning storms moved away, but the stars returned. That reliability mattered. Human life on the ground was unstable. Rivers flooded or dried. Trees fell. Animals migrated. Fires went out. Bodies aged. Children became adults. Parents disappeared. Camps moved. Villages rose, changed, and vanished. Against that restless surface, the sky seemed almost permanent. Not perfectly permanent, as we know now. Stars have proper motions. Earth's axis slowly wobbles in a cycle called precession. Over many thousands of years, the sky's patterns shift. But within a human lifetime, and even across many generations, the constellations appear astonishingly stable. Orion returns in winter. The Pleiades rise in their season. The northern stars wheel around a fixed point. The moon renews itself. The sun comes back along the horizon. For people living without written calendars, that stability was not poetic decoration. It was structure. The sky offered a kind of order that the ground could not. This may be one reason so many cultures place sacred meaning above them. The sky was high. It was unreachable. It was bright. It seemed older than human trouble. It watched everything and could not be touched. Those qualities are powerful. A thing you can use every day becomes ordinary. A stone, a branch, a tool, a bowl, a wall. Useful, familiar, handled. A thing you can see but never reach stays different. The sky belonged to that category. It was present, but not available. close enough to shape life, too far away to possess. Sacredness often grows in exactly that distance. We can see this in many early civilizations, though we have to avoid making every culture sound the same. The details matter. In ancient Egypt, the night sky was deeply tied to death, kingship, and renewal. The pyramid texts speak of the dead king joining the imperishable stars, the circumpolar stars that never set. To the Egyptians, stars were not merely lights. They could be destinations, companions, forms of eternity. Some shafts in the Great Pyramid have been interpreted as pointing toward important regions of the sky, including areas associated with Orion, Sirius, and northern circumpolar stars. The exact meaning of these alignments is still debated, and we should not pretend certainty where scholars do not have it. But the broader point is clear enough. The sky mattered to Egyptian religion. The upward journey mattered. The stars were part of how eternity was imagined. In Mesopotamia, the connection was different but just as strong. The Sumerian sky god, and represented the heavens themselves. Later, Mesopotamian traditions filled the sky with divine signs, planetary movements, and omens. Temples were built as ziggurats, massive stepped platforms rising above the flat city landscape. A ziggurat was not just a tall building, it was a structured ascent. At the top stood a shrine, a place associated with the presence of the god. The building made a statement in brick. Earth reaches upward. The divine descends. The meeting point is height. In Mesoamerica, pyramids and temple platforms also joined architecture, ritual, and the sky. Maya observers tracked the sun, the moon, Venus, and eclipse cycles with remarkable care. Some ceremonial buildings were aligned with solstices, equinoxes, or significant horizon events. Again, the meanings were not identical to Egypt or Mesopotamia, but the gesture is familiar. Building upward, watching the horizon, connecting public space to celestial order. Mountains carried similar power in many places. They rose above ordinary life. They met weather first. Clouds gathered around them. Lightning struck them. Their summits seemed nearer to the region where gods, ancestors, or spirits might dwell. The same pattern appears in trees, towers, high altars, hilltop shrines, pagodas, stupas, minarets, church spires, and later skyscrapers. Not all of these belong to the same religion. They do not mean the same thing. But human beings keep using height to express importance. We lift what we honor. We place sacred things above the ordinary eye line. We climb when we want perspective. That habit may be very old. The sky was the first vast thing that could be seen but not entered. It was the first visible elsewhere. The sea was large, but you could touch it. A forest was mysterious, but you could walk into it. A mountain was difficult, but climbable. The sky remained beyond reach. For tens of thousands of years, no hand could touch a star. No ladder could reach the moon. No road could arrive at Venus. The upper world was visible and inaccessible at the same time. That combination creates pressure on the imagination. If something is powerful and unreachable, we tend to make it meaningful. If it is meaningful and patterned, we tend to make it speak. And if it speaks, we begin to listen. This is where the sacred sky becomes more than a ceiling. It becomes a system of signs. A storm can mean anger. A comet can mean warning. A star that returns at the right season can mean planting, travel, migration, or ritual. The moon can mark time. The sun can order the year. A bright planet can become a goddess, a warrior, a messenger, a judge. The sky becomes a map of more than space. It becomes a map of value. Up there, permanence. Up there, memory. Up there, the dead, the gods, the future, the calendar, the warning, the promise. Modern knowledge changed the content of that map. A star is not a jewel fixed to a dome. It is a sphere of plasma, mostly hydrogen and helium, producing light through nuclear fusion. The moon is not a polished lamp. It is a rocky body with craters, dust, mountains, and a history of impacts. The blue above us is not a solid vault. It is atmosphere scattering sunlight. We know more now. But knowing more did not end the upward pull. People still climb mountains to feel something open inside them. We still build towers with observation decks. We still look out of airplane windows, even when we know exactly what clouds are. We still stop under a dark sky when the Milky Way appears. The old sacredness has changed form. It has not completely disappeared. It moved into wonder, into science, into photography, into the feeling a person gets when they see Earth from orbit, or the moon through a telescope, or Saturn's rings for the first time. The language changed. The gesture remained, lifting the head, looking up, trying to place ourselves inside something larger. That is where this first part leaves us. The sky began as a presence, bright, regular, unreachable. Then it became a source of questions. Rare events made people search for causes. Stable patterns made people search for order. Height, distance, and repetition made the heavens feel sacred. But sacredness alone was not enough. People needed to remember what they saw. They needed to pass it on. They needed the sky to hold not only fear and reverence, but images. So they began connecting the lights. They gave the dark spaces figures. They turned points into animals, hunters, sisters, rivers, tools, gods. And once the sky had figures, it could carry stories. At some point, looking became arranging. The stars were already there. They did not need us to invent them, but the lines between them, those were ours. A single star is only a point of light. 2 stars suggest a line. 3 can become a triangle. Add a few more and the brain begins to work. It tests shapes. It looks for edges. It compares one brightness to another. Before long, those scattered points begin to resemble something. A hunter, a bear, a scorpion, a boat, a bird, a bowl, a path. This is not a failure of reason. It is one of the ways reason begins. The brain is very good at finding patterns, even where the pattern is incomplete. We see faces in clouds. We see a person in a shadowed doorway. We notice a shape in the cracks of an old wall. Sometimes we're wrong, but the habit itself is useful. Long before cities, long before writing, it was safer to mistake a branch for an animal than to mistake an animal for a branch. That same pattern-making instinct turned upward. The sky was not random to the eye for long. Humans connected the bright points, then remembered the shape, then attached the shape to a story. Once that happened, the sky was no longer just a ceiling of lights. It became organized memory. Orion is one of the clearest examples. In the northern winter sky, Orion is hard to miss. 3 bright stars sit in a straight line, forming what we now call the belt. Around them are brighter and dimmer stars that can become shoulders, knees, a lifted arm, a weapon, and animal skin. To Greek storytellers, Orion became a hunter, large enough to be placed among the stars. The story did not stay alone. Scorpius, the scorpion, was placed in the sky as well, far away from Orion. When Scorpius rises in the summer, Orion is gone. When Orion returns in winter, Scorpius is set. That is a story, yes, but it is also information. It tells you something about the year. Orion belongs to one season, Scorpius to another. The drama between them makes the seasonal pattern easier to remember. A child may forget a list of star positions, but a hunter chased by a scorpion is harder to lose. That is one reason sky stories lasted. They were not only decoration, they were memory systems. Different cultures looked at the same stars and built different systems from them. What many people now call the Big Dipper is not a constellation in itself, but an asterism, a recognizable shape inside a larger constellation. In North America, many people see a ladle or dipper. In ancient Egypt, related stars were sometimes imagined as the foreleg of a bull. In China, the same pattern was known as the Northern Dipper, a celestial ladle turning around the pole. In India, the 7 stars were the Sapta Rishi, the 7 sages. In several indigenous traditions of North America, the stars were connected with a great bear and hunters moving across the sky. The stars were nearly the same, the meanings were not. The Pleiades show this especially well. To the naked eye, the Pleiades look like a tiny knot of blue-white sparks. Many people can see 6 or 7 stars, Under darker skies, some see more. The cluster is compact, memorable, and easy to recognize, which made it useful across cultures. In Greek tradition, they became the Seven Sisters. In Japan, the same cluster is connected with the name Subaru. In Aotearoa, New Zealand, Matariki, associated with the Pleiades or closely related stars depending on tradition, marks a seasonal turning point and the beginning of a new year in Maori culture. That is the important thing. A star cluster was not merely looked at. It was used to organize time, identity, and communal memory. The sky did not create one story. It created a space where many stories could attach to the same lights. That variety matters. It reminds us that the night sky has never belonged to a single culture. The sky offered the same lights, but each community brought its own animals, tools, fears, seasons, rivers, gods, and jokes. The stars were fixed enough to be shared, but open enough to be interpreted. And because there was no writing, interpretation had to travel by voice. A person pointed upward and told another person what the shape meant. That person told it again, perhaps slightly differently. A name shifted. A detail changed. A hunter became taller. A bear moved farther across the sky. A scorpion became more dangerous. This is not a flaw in oral tradition. It is how living memory works. The important part stayed because the sky kept returning to remind people. Every winter, Orion came back. Every year, the Pleiades appeared again. Every night, the Dipper turned. The stars acted like prompts. A storyteller did not have to carry the whole memory alone. The sky helped. A story attached to a visual anchor becomes very difficult to erase. That is why constellation stories could survive for thousands of years. The sky refreshed them. Night after night, season after season, the old shapes returned in the right place. The human voice supplied the meaning, but the stars supplied the structure. This is also why the stories are not only myths in the modern casual sense of the word. They are not simply false explanations from people who did not know better. They are cultural tools. They helped people remember directions, seasons, animals, rituals, planting times, hunting times, and the moral order of the world. Today, professional astronomy uses official constellations with defined borders. There are star charts, coordinates, catalogues, and databases. But under all of that formal astronomy sits something older, the simple act of recognizing a pattern and giving it a name. Most of us did not discover Orion ourselves, or the Big Dipper, or Taurus, or the Pleiades. Someone gave those shapes to us. They received them from people before them, and those people from others before that. The chain is long, maybe longer than we can honestly measure. Now return to the sky. A person looks up. They do not see a database. They see a few bright points that resemble something familiar. They say a name. Someone else remembers it. A child hears it. The child grows old and says the name again. That is how the sky became a library before there were libraries. Not a library made of shelves and paper. A library made of light, repetition, and memory. And once humans began using the sky to remember stories, it was only a small step toward using it to remember something even more practical. Time. The stars were not just pictures. They moved. Not because the stars themselves were circling Earth each night. We know now that the daily motion is caused by Earth turning on its axis. Earth rotates from west to east, and because of that the stars appear to drift from east to west across the sky. But to an early observer the effect would have been simple. A star rises, it climbs, it crosses the darkness, it sets. The same motion happens again the next night, and the next, and the next. At first, that may have seemed like the whole pattern, but the sky was doing something more complicated than that. The night sky also changed with the seasons. A constellation visible in winter might be gone in summer. A group of stars that rose before dawn in 1 month might appear earlier in the evening a few months later. The change is slow enough to miss if you only look once in a while, but regular enough to become obvious over the years. One person could notice pieces of it. A community could hold the whole thing. This is where the sky becomes more than beautiful. It becomes a measuring instrument. The daily rising and setting of stars gave people a rhythm of night. The changing moon gave a rhythm of weeks and months. The seasonal return of certain stars gave a rhythm of the year. Together, these cycles made time visible. There is a subtle but important correction here. We should not say that the sky invented time for human beings, as if people had no sense of before and after without astronomy. Every living creature understands some form of sequence. Hunger comes, rain comes, wounds heal, children grow. What the sky offered was something larger and more countable. It allowed people to connect local experience to cycles beyond the body. A stomach can tell you when a day has passed. The sky can tell you when a year is returning. Not time as an abstract idea on a clock face. Time as recurrence, the return of light, the return of darkness, the return of a star, the return of a cold season, the return of rain. The moon was the easiest teacher. It changes shape in a way no star does. A thin crescent appears. It grows night by night, becomes full, then shrinks again, then disappears into darkness before returning. That full cycle, from one new moon to the next, takes about 29.5 days. You do not need mathematics to notice that. You need attention. One moon passes, then another, then another. Soon you have a count that is larger than a day and smaller than a year. In many languages, including English, the words for moon and month are related for exactly this reason. The moon was one of humanity's earliest measuring devices. But a lunar year is not the same as a solar year. 12 lunar cycles add up to about 354 days, roughly 11 days shorter than the solar year. That mismatch created a problem for later calendar makers. If you only count moons, the seasons slowly drift. Planting days move. Festivals slide. A calendar can lose touch with the weather. This is why so many ancient calendars had to add extra days or extra months. They were not just counting. They were reconciling two different rhythms in the sky, the moon's cycle and the sun's year. The stars helped with that. There were also patterns made by the sun itself. A person watching the horizon carefully would notice that the place of sunrise changes throughout the year. It does not rise from exactly the same point every morning. It creeps northward for part of the year, then southward again. The turning points are what we now call solstices. The middle crossings are the equinoxes. You do not need a written calendar to notice this, but you do need patience and a fixed place to watch from. A stone, a post, a notch in a ridge, a doorway, a shadow on the ground. Any of these can become a measuring device if you return to it often enough. This is one reason ancient monuments and stone arrangements attract so much attention from archaeologists and archaeoastronomers. Some align clearly with solar events. Others are more uncertain. It is easy to overclaim. Still, the general point is safe. Humans learned to use horizons, shadows, lunar phases and star risings as ways of turning the sky into a calendar. The sky was not only above them, it was becoming mapped onto the land. Some stars and star clusters become visible at very specific times of year. One of the most important events is called a heliacal rising. It is the first morning when a star becomes visible low in the east just before sunrise, after being hidden for a period by the sun's glare. That moment can function like an annual alarm. The star appears at dawn. A season is changing. Something needs to be prepared. To us that may sound delicate. To ancient communities it was practical knowledge. You could not ask a phone what month it was. You could not open a printed calendar. The sky itself was the display, and the display had to be memorized. This is the part that is easy to underestimate. Before writing, a community could know a great deal about the sky. Which stars rose in which season, which moon was associated with which animal behavior, which dawn star meant a river would soon rise, which evening star marked a time to travel, harvest, hunt, fish, or hold a ceremony. That knowledge lived in trained attention. It lived in memory, song, story, repeated watching, and correction by elders. If someone made a mistake, the sky would eventually correct them too. The pattern came back every year. Still, memory alone has limits, so people began to mark things. They cut notches into bone. They painted animals on cave walls. They placed stones in lines. They carved signs whose meanings we still argue about. Some of those marks may have had nothing to do with astronomy. Some may have recorded animals, rituals, migrations, or counts of days. But in a few cases, researchers have suggested a connection with the sky. Lascaux in France is one famous example. The cave paintings there are about 17,000 years old. Among the bulls and horses are clusters of dots and signs. Some archaeoastronomers have proposed that a small group of dots near a bull might represent the Pleiades, the bright star cluster that later became associated with Taurus, the bull. It is a tempting idea. The Pleiades really are visible to the naked eye. They really do sit near Taurus in the modern sky. They really have been important to many cultures as seasonal markers, but we have to be honest. We do not know whether the Lascaux dots were meant as stars. The interpretation is possible, not proven. Prehistoric art is not a caption diagram. We are looking across 17,000 years at marks whose makers cannot explain themselves to us. So the best language is careful language. Not, this is a star map. Better, this may be one of the earliest hints that people were connecting animal images, seasonal life, and the night sky. There is a similar caution around a small piece of mammoth ivory found in Germany, dated to roughly 32 to 35,000 years ago. Some researchers have suggested that the figure carved into it may relate to Orion. Others see it differently. Again, the claim is intriguing. Again, it is not settled. That uncertainty is not a weakness in the story. It is part of the story. The farther back we go, the less the evidence behaves like a clear sentence. It behaves more like a fragment, a mark, a cluster, a bone with notches, a painted animal in darkness. We should not force those fragments to say more than they can say, but we also should not miss what they suggest. Long before formal astronomy, long before observatories, long before anyone wrote a table of planetary positions, people were paying close attention to regular patterns above them. They noticed, they remembered, they probably counted, and sometimes they marked what mattered. That is already extraordinary. Today, recording is effortless. A phone can photograph the moon in a second. A calendar app can remind us of the next eclipse. Software can simulate the night sky 10,000 years into the past or future. Because recording is so easy now, it can be hard to understand what memory once required. For ancient observers, remembering was work. It took repetition. It took patience. It took a community. And it mattered, because the sky was not only telling stories, it was beginning to tell people when to act. When the Pleiades returned, a season had shifted. When the moon was full, a night had changed. When a star rose before dawn after months of absence, the year had turned a corner. The sky had become a calendar. And once a calendar exists, a new question appears. Not just, what time is it? But, what should we do now? A calendar is not only a way of counting, it is a way of reducing risk. That becomes clear with farming. Around 12,000 years ago, in several parts of the world, some human communities began to rely more heavily on cultivated plants and managed animals. It did not happen all at once, and it did not happen the same way everywhere. But wherever farming took root, time became more dangerous. A hunter can respond to what is moving today. A farmer has to make a decision months before the result. Plant too early and frost can destroy the crop. Plant too late, and the heat may come before the grain is ready. Harvest too soon, and the food is not mature. Wait too long, and rain, birds, insects, or rot can take what you have grown. A mistake was not just inconvenient. It could decide whether a village had enough food for winter. So the sky became practical. In ancient Egypt, one of the most famous examples was Sirius. Sirius is the brightest star in the night sky. For part of the year it is hidden in the sun's glare. Then, at a certain point, it becomes visible again just before sunrise. That first dawn appearance is its heliacal rising. For the Egyptians, the heliacal rising of Sirius was closely associated with the season of the Nile flood. The Nile's annual inundation was the foundation of Egyptian agriculture. Floodwater spread over the land, then withdrew, leaving dark, fertile silt behind. If you knew the flood was coming, you could prepare fields, manage labour, move animals, and organise the work of the year. So the rising of Sirius was not a pretty detail in the morning sky. It was a signal. A star had become part of an agricultural system. The Egyptians also developed star clocks, using groups of stars called decans to divide the night into portions of time. That is worth pausing over. A civilization was not only watching the sun for the day and the moon for the month, it was watching stars to measure the hours of darkness. The night had been organized. The Egyptian calendar eventually settled into a civil year of 365 days, 12 months of 30 days plus 5 extra days. It was not perfect by modern astronomical standards, but it was an extraordinary administrative tool. Taxes, temple rituals, labor, irrigation, and harvest could be coordinated across a complex society. That is what calendars do. They let large groups of people act together. A calendar is not just astronomy, it is infrastructure. Other cultures did similar things in their own ways. In ancient Greece, Hesiod's works and days gave farming advice tied to the Pleiades. When the Pleiades rose, it was time to begin the harvest. When they set, it was time for ploughing. This was poetry, but it was also instruction. A farmer could look up and know where the year stood. In Mesopotamia, later astronomical texts connected stars, months, winds, and agricultural tasks. In ancient China, state astronomy was tied to calendars, ritual order, and the timing of work. Across the world, different communities developed different systems, but the principle was similar. The ground depended on the sky. The seed in the soil was linked to the star on the horizon. That link may sound poetic now. For many people in the ancient world, it was ordinary survival, and the sky did not only guide the farmer, it guided the traveller. Navigation is one of the most impressive uses of sky knowledge, especially when we look at the Pacific. Polynesian wayfinders crossed enormous distances of open ocean without modern instruments. No GPS, no printed nautical chart in the European sense, no magnetic compass required, just a canoe, trained memory, disciplined observation, and a world of signs. The stars were central. A wayfinder used the rising and setting points of stars on the horizon as a mental compass. In the Hawaiian star compass, for example, the horizon is divided into named houses. A star rises from one part of the horizon, travels across the sky, and sets in a corresponding place. By knowing those paths, a navigator can hold a direction through the night. But the stars were only one part of the system. Wayfinders also read ocean swell, wind, bird behavior, cloud shapes, currents, and the color of water. Islands disturb waves. Birds travel out from land and return. Clouds can gather above islands. Reflections from lagoons can tint the underside of clouds. None of these signs is enough by itself. Together they form a navigational field. This is not guesswork, it is trained perception. A modern person might see an empty ocean. A wayfinder sees directions, distances, tendencies, warnings, and probabilities. The knowledge is not stored only in words. It is held in the body too, in balance, in attention, in the feel of the canoe, in the memory of how one swell crosses another. That matters because navigation by sky and sea was not simply instinct or luck. It was an intellectual achievement. It required years of training and a precise mental model of the world. It was science before instruments looked like science. European, Arab, Indian Ocean and Mediterranean sailors also relied on the sky. Polaris, the North Star, was especially useful in the Northern Hemisphere because its height above the horizon roughly matches the observer's latitude. Mariners used stars together with tools that developed over time: the astrolabe, the quadrant, the cross-staff, later the sextant. The sextant became common in the 18th century, but the habit behind it was far older. There is another detail worth adding. Finding latitude with stars is easier than finding longitude. In the Northern Hemisphere, Polaris gives a rough guide to latitude because its height above the horizon roughly matches how far north you are. Sailors could measure that height with instruments and estimate their north-south position. East-west position was much harder. For that, you need accurate timekeeping, because Earth turns 15 degrees every hour. Until precise marine chronometers became reliable in the 18th century, longitude remained one of navigation's great problems. So the sky gave direction, but not all directions equally. It offered clues. Humans still had to build tools, tables, and methods around those clues. Look up, measure, compare, remember, correct. That is the same chain again. The sky gave direction at sea. It gave seasons on land. It gave hours in the night. It connected stories to memory and memory to action. This is what we have mostly lost in daily life. Not because modern tools are bad, they are astonishing. GPS is one of the quiet miracles of modern life. A phone can locate you by listening to satellites carrying atomic clock time signals from orbit. In a very strange way, we still navigate by the sky. We have just moved the stars into machines. The irony is that modern navigation has not really abandoned the sky. GPS works because satellites orbit above us, each carrying extremely precise clocks. Your phone calculates its position by comparing signals from several of those satellites. So the ancient problem is still there. Where am I under the heavens? The method has changed completely, but the geometry is still celestial. We no longer steer by stars. We steer by artificial stars that we built and placed in orbit, but something changed. Most of us no longer know the sky directly. We follow arrows on a screen. We let software name the constellations. We use calendars without knowing which moon they came from. We cross oceans by coordinates, not by memorized star paths. Not exactly a moral failure, more like a trade. We gained precision, speed, safety, and reach. We lost a certain kind of attention. For most of human history, the night sky was not background. It was information. It was a seasonal chart, a memory palace, a warning system, a compass, a clock, and sometimes a sacred text. The same stars that became stories also became tools. That is why people kept looking up for so long. Every light could mean something, a direction, a season, a task, a danger, a promise of rain, a time to leave, a time to wait. But then another change began. Looking was no longer enough. Memory was no longer enough. Humans wanted to hold the sky still, so they began to write it down. A clay tablet fits in the hand, not paper, not stone, not a screen. Just river clay, softened with water, shaped into a small rectangle, and held while it is still damp. A reed presses into it, not drawing lines exactly, but leaving small wedge-shaped marks. One mark, then another. A row, a count, a name, a date. At first, writing was practical. Grain, sheep, beer, land, taxes, a debt owed by one person to another. Early writing in Mesopotamia grew out of the need to keep track of things that could be lost, disputed, or forgotten. That is already interesting. Writing did not begin as poetry. It began as memory with a hard edge. A way to say, this happened, this was counted, this belongs here. And once people had a tool like that, the sky was too important to leave out. Because the sky repeated. A star rose again after being absent for months. The moon returned to fullness. Venus appeared in the evening, vanished, then later returned before dawn. Eclipses were rarer, more alarming. But even they belong to patterns people hope to understand. If something repeats, it can be watched. If it can be watched, it can be recorded. And if enough records survive, someone later can compare them. That is the quiet beginning of prediction. Before writing, the sky lived mostly in memory. After writing, some of it could sit on a table. This is where the story becomes less dreamy and much more impressive. In southern Mesopotamia, scribes began to collect observations of the sky with a patience that is hard to imagine now. Not because they had modern science. They did not. Their world was still full of gods, omens, rituals, royal anxiety, and sacred interpretation. But they had something modern science still depends on. Records. A scribe could write that Venus appeared on a certain day, that it disappeared on another, that the moon was eclipsed, that Mars was unusually bright, that a halo had formed around the moon, or that a planet had stood near a particular star. The observations were not neutral in the way a modern astronomy textbook tries to be. They were often tied to omens, A certain planet in a certain place might be read as danger for a king, famine for a land, success in war, trouble in the palace. To us, that combination can look strange. Data and prophecy, mathematics and fear. Careful observation, written beside political warning. But in that world, the categories were not separate yet. The sky was not only physical, it was administrative, religious, agricultural and royal at the same time. A bad omen in the heavens was not a private feeling. It could become state business. That matters because it helps explain why the records became so detailed. Kings cared, temples cared, farmers cared. If the sky might speak about the future of the city, someone had to watch it carefully. So they watched, night after night, rain after rain. One of the most famous examples is usually called the Venus tablet of Amisaduqa. The tablets we have are later copies, but they preserve a much older record. Observations of Venus connected with the reign of a Babylonian king named Amisaduqa. In the 2nd millennium BCE, Venus was worth the attention. It is the brightest planet in the sky. Sometimes it appears after sunset, low in the west. Sometimes it appears before sunrise in the east. It is never far from the sun in our sky, so it seems to belong to the edges of day, evening and morning, disappearance and return. For people who read the sky as a language, that cycle was loaded with meaning. The Venus tablet records appearances and disappearances of the planet over a long span. Scholars still study it today, though not because it gives simple answers. It is complicated. The tablets are copies. The dates are debated. Observing Venus near the horizon is affected by the atmosphere, weather, and visibility. Still, the existence of the record is remarkable. Someone cared enough to write down not only what Venus was, but when it came and went. That is a different relationship with the sky, not just awe, tracking, not just fear, a ledger. And once the sky entered the ledger, it became possible to argue with it, to compare this year with the year before, to ask whether an event had happened before and what followed it. The results were not always scientifically correct, but the habit was powerful. Observation, record, comparison, pattern. Those 4 things are part of the long road to astronomy. The road did not stay in one place. Babylonian records influenced Greek astronomy. Greek geometrical models later entered the scholarly worlds of Alexandria, Baghdad, Damascus, Cordoba, Toledo, Sicily, and eventually medieval Europe. In Abbasid Baghdad, astronomers translated, criticized, recalculated, and improved inherited materials. They did not simply carry old knowledge like a sealed box, they worked on it. Centuries later, in 15th century Samarkand, Ulugh Beg built an observatory and produced one of the most accurate star catalogues before the telescope. Different city, different language, same old project. Look up, write down, correct the record. The chain is not clean and simple. It breaks, restarts, gets translated badly, gets improved, gets forgotten, gets found again. But that makes it more human, not less. The sky became a shared notebook, written in many hands, and writing changed what the sky meant. A star was still a star, a planet was still a moving light, but once it had a place in a table, a date beside it, a repeated pattern attached to it, it was no longer only part of the view, it had become information. That word sounds dry, almost too modern for this ancient world, but the shift is real. To record something is to bring a piece of it closer, not to control it completely, but to hold it in a human system. A mark on clay says, "We saw this. We noticed. We expect it may matter again." The sky was still enormous, but a small part of it now fit in the hand. There was one more step. The lights up there needed names. A name changes the way a thing lives in the mind. Before a name, a light is only that. A light. Bright, maybe. Red, maybe. High in winter, low in summer, but hard to hold on to. After a name, it can be remembered. It can be pointed out to a child, written in a list, compared across languages, built into a calendar, a prayer, a story, a warning, a poem. Naming is one of the oldest ways humans turn the world into something shareable. The sky needed that. There were too many lights to remember as anonymous points, so humans began to sort them, some by brightness, some by colour, some by position, some by the stories already attached to the constellations around them. Sirius, for example, comes from Greek, from a word connected with scorching or glowing. It fits. Sirius is the brightest star in the night sky, and it can flash with a sharp white-blue intensity when it is low near the horizon. Vega comes through Arabic star tradition. One of its old Arabic names referred to a falling or swooping eagle. The image stayed attached to the star as the name moved through languages. Aldebaran also comes from Arabic, Aldebaran, the follower. It appears to follow the Pleiades across the sky, a red eye trailing behind that small cluster of blue-white stars. These are not random labels. They are observations compressed into sound. Bright, burning, falling, following. A person looked carefully, found a comparison, and the comparison survived. Many traditional star names used in Western astronomy came through Arabic, especially because medieval Islamic astronomers preserved and expanded star catalogues, while Europe later received many of those names through translation. Other names came from Greek, Latin, Babylonian, Egyptian, or other older traditions. Today, the official naming of stars tries, at least in principle, to respect a wider range of human sky traditions. That is the beautiful thing here. When we look up, we are not looking through one culture. We are looking through layers. A star might carry an Arabic name. A constellation might carry a Greek myth. A planet might carry a Roman god. The mathematics used to predict its movement might have roots in Babylon, Alexandria, Baghdad, or somewhere else entirely. The sky did not belong to one language long enough to be owned by it. It passed through too many hands. That is rare. Human history is full of borders, claims, erasures, and arguments over ownership. But the sky was too large for any one empire to close around it. Every culture could name part of it. None could finish the job, so the old names accumulated. Some survived because they were practical, some because they were beautiful, some because a later scholar copied them into the right book at the right time. That is how fragile cultural memory can be. A name can last for 2,000 years, or vanish because one manuscript burned. The names of the planets followed another path. In Mesopotamia, celestial bodies were closely tied to gods. Ishtar, or Inanna, was associated with Venus, and with love, sex, and war. Shamash was the sun god, connected with justice. Sin, or Nana, was the moon god, tied to the lunar cycle and time. Later Greek and Roman traditions placed their own divine figures onto the planets: Jupiter, Venus, Mars, Mercury, Saturn. We still use those names. Even the week carries this old sky language. Saturday is Saturn's day. Sunday and Monday still belong plainly to the sun and the moon. Tuesday, Wednesday, Thursday, and Friday carry Germanic gods that were mapped onto Roman planetary gods as the names moved between cultures. Most of the time, we say these words without hearing the old astronomy inside them. But it is there. Every calendar on a refrigerator, every work meeting scheduled for Thursday, every casual complaint about Monday morning, all of it carries a faint echo of the old planet week. This is where naming becomes more than labelling. Names let knowledge travel. If a star has a name, you can teach it. If a planet has a name, you can track it. If a constellation has a name, a story can attach to it and survive the person who first told it. Without names, the sky is magnificent but slippery. With names, it becomes a map. But naming also does something more dangerous. It makes the sky feel personal. Aldebaran is not just a red star now. It is the follower. Mars is not only a reddish planet, it is the war god. Venus is not only a bright point near dawn, it is desire, beauty, conflict, and return. The light becomes a character, and once the sky is full of characters, the next question almost asks itself. If they move, do they mean something? And if they mean something, are they speaking about us? Astrology did not begin as personality content. That is important to say because modern astrology often reaches us through apps, memes, birth charts, compatibility posts, and little jokes about Mercury retrograde. It feels intimate, casual, sometimes playful. But the older system was much heavier than that. In Mesopotamia, the sky was first read for kings and states. The question was not, will this ordinary person be sensitive or ambitious? The question was closer to, is the king in danger? Will the harvest fail? Is war coming? Is the city protected? The sky spoke about public fate before it spoke about private identity. That makes sense in the world that produced it. If the king embodied the state, then a sign in the heavens could be taken as a sign about the land itself. An eclipse might be read as a warning. A strange planetary arrangement might suggest danger, abundance, rebellion, disease, or victory. There were manuals for this. A celestial event would be recorded, then interpreted through earlier cases. If this happened in the sky, what happened afterward on Earth? Was there famine? A death in the palace? A military defeat? A flood? A successful campaign? To modernize, the assumption underneath this is not reliable. The position of Mars does not cause a war simply because Mars is seen near a star. But the method had a surprisingly disciplined shape. Watch the sky. Keep records. Compare events. Look for recurrence. Wrong cause. Useful habit. That is one of the strange themes in the history of knowledge. People can be mistaken about why something works and still develop tools that matter. Astrology helped preserve observations. It encouraged calculation. It gave sky watchers a reason to keep watching with unusual care. The history of astronomy and astrology was not cleanly divided at first. For a long time they grew from the same root. The split came later. The zodiac is part of that shared root. The zodiac is the band of sky along the ecliptic, the apparent path the sun follows through the year. The moon and the visible planets also move close to that same band, which made it the natural stage for both astronomy and astrology. By about the first millennium BCE, Babylonian sky watchers were developing systems that divided this path into signs. By around 500 BCE, the zodiac was divided into 12 equal signs, each covering 30 degrees of the Great Circle, 12 sections, a year broken into celestial order: Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, Pisces. Some of these names and figures were inherited, adapted, or reinterpreted as the system moved from Babylonian to Greek worlds. The Greek word behind zodiac means something like a circle of animals, though the signs are not all animals. They became a mixture: animal, human, object, hybrid, memory, the ram, the bull, the twins, the crab, the lion, the maiden, the scales, the scorpion, the archer, the sea goat, the water bearer, the fish, a calendar, but also a cast of characters. In Hellenistic astrology, the system became more personal. The sky at the moment of birth mattered. A chart could be drawn. Planets had positions. The rising sign marked the eastern horizon. The moon sat in one sign, the sun in another. Houses divided the life into themes: body, wealth, siblings, home, marriage, death, travel, career. The universe had become a diagram of the person. This was a huge shift. The old question was, what does the sky say about the king? The newer question became, what does the sky say about me? That question has never really gone away. You may not believe in astrology at all. Many people do not, but you probably know your sign. You may have smiled at a Mercury retrograde joke. You may have met someone who asked for your birth time before they knew your middle name. That small modern moment is not as random as it looks. It is a very old habit, wearing a phone case. The desire underneath it is familiar, to feel that your life has a pattern, that your timing means something, that your personality is not just a pile of accidents. This is why astrology keeps returning. Not because it has become science, it has not, but because it answers a different hunger. It gives shape to uncertainty. It turns private confusion into a language. It lets people say, I am like this for a reason. This difficult week has a weather system. This attraction, this fear, this strange mood. Maybe it belongs to something larger. That can be comforting. It can also be misleading. Both things can be true. In the ancient world, Astrology was one of the most organized and respected systems of knowledge available. Roman emperors consulted astrologers. Chinese courts employed sky watchers to monitor unusual celestial events and link them to imperial order. In Indian traditions, astrological timing became deeply connected with ritual, marriage, and social life. It was not just entertainment, it was government, religion, medicine, marriage, agriculture, and psychology before those categories had separated cleanly. That is why dismissing it too quickly would be a mistake. The old astrologers were not simply foolish people staring upward and inventing things. Many were trained observers using mathematics, records, and inherited interpretive systems. The weak point was not their patience. It was the assumption that the sky's patterns directly described human fate. Modern astronomy eventually removed that assumption, or at least tried to, but the need that astrology served did not disappear. It only changed costume. Today we have algorithms recommending what we might like, personality tests sorting us into types, health apps turning bodies into charts, finance apps making little predictions, dating apps turning desire into categories. We may laugh at ancient sky readers. Then we open a screen and ask another system to tell us who we are, what will happen, and what we should do next. The surface changed. The question stayed. What does the pattern mean? That is where part 3 needs to leave us. Humans had watched the sky, then written it, then named it, then asked it for answers. But once you begin asking for answers, another question eventually arrives. A harder one. What if the answer is wrong? What if the sky is not speaking in the way we thought? What if the stars are not characters, not warnings, not personal messages, but physical things moving according to rules? At that point, the old sky language begins to tremble, and a new kind of mind enters the story. Not the believer, not the poet, the doubter. If you're still here, this is the kind of path this channel is built for. Not escape from reality, but a longer way of looking at it. Following wisdom in rest helps us keep making these slower, research-shaped journeys without sanding away their wonder. Around the early 6th century BC, on the western coast of Anatolia, there was a port city called Miletus. It sat near the Aegean, in what is now western Turkey. Ships came and went. Goods moved through its harbours, so did stories, measurements, rumours, techniques, and old ideas travelling in new languages. In that city lived a man later remembered as Thales of Miletus. We have to approach him carefully. Thales did not leave us a book we can open. If he wrote one, it has not survived. Almost everything we know comes from later Greek writers looking back at him from a distance. That means the edges of his life are blurry. Still, the outline matters. Later tradition describes him as a thinker, a mathematician, a practical man, perhaps a merchant, perhaps a traveller. He was said to have learned geometry from Egypt. Some stories connect him, directly or indirectly, with Babylonian astronomical knowledge. We should not treat every detail as certain. Ancient biographies often made their heroes more polished than real life ever is. But behind the legends, one important thing seems to remain. Thales became associated with a different kind of question. Not only, which god did this, but what natural process might be underneath it? That shift sounds small now. It was not small then. For a very long time, storms, earthquakes, eclipses, droughts, and unusual lights in the sky had lived inside sacred explanation. The world was animated. It had wills inside it. Thunder could be the voice of a god. The sea could be angry. The sun could be threatened. The heavens could send warnings. Thales did not simply walk into that world and remove the gods from it. History rarely moves that cleanly. A better way to say it is this: he helped make room for another layer of explanation. The sacred could remain, but nature might also have habits. Lightning might still feel divine, but perhaps it also followed conditions in the air. An eclipse might still terrify a city, but perhaps the sun and moon were moving according to a pattern. A flood might be read as a sign, but it might also depend on seasons, rivers, rain, and geography. Two explanations could stand side by side for a while. That is often how old worlds change, not by collapsing all at once, but by gaining a second language. To us, natural explanation feels ordinary. If the sky darkens at noon, we check the eclipse map. If a storm is coming, we look at pressure systems and satellite images. If the ground shakes, we talk about tectonic plates. We may still feel awe or fear, but we do not usually imagine that the event has no physical cause. In Thales' world, that habit of thought was not yet normal. The famous story is about an eclipse. According to Herodotus, Thales had foretold a solar eclipse during a war between the Lydians and the Medes. The usual date given is May 28th, 585 BC. The two armies were fighting when daylight suddenly failed. The sun went dark. The battlefield stopped. Herodotus says both sides took the event as a sign and made peace. It is a striking image. Two armies ready to kill one another, and then the sky interrupts them. But we should be honest about the uncertainty. Scholars still debate whether Thales really predicted that eclipse, and if he did, what kind of prediction it was. He may not have known the exact day. He may have predicted only the year, or a rough period. He may have been using patterns learned from older Mesopotamian records, or the story may have become neater with time, as famous stories tend to do. The point is not that Thales stood there with modern eclipse mathematics. He did not. The important thing is that the story remembers him as someone who believed the sky could be anticipated. That belief matters. You cannot meaningfully predict a god's temper. You can only appease it, fear it, interpret it afterward. But if an eclipse is a natural event produced by regular motions, then it belongs to calculation. Maybe not perfectly yet, maybe clumsily, but in principle it can be known before it arrives. That is the doorway. A frightening sign becomes a recurring event. A recurring event becomes a pattern. A pattern becomes something a human mind can work with. It is easy to miss how radical this is, because we live after the change. Prediction surrounds us so completely that we barely notice it. The weather app tells you when the rain will start. Your calendar tells you when the moon will be full. Your phone knows sunrise and sunset before you wake up. Airplanes cross oceans because position, speed, weather, fuel, and time can be calculated in advance. Modern life is built on prediction. The older world had prediction too, of course. Farmers watched seasons, sailors watched winds, hunters read tracks. But celestial prediction gave that habit a new authority. The sky was vast, distant, untouchable. If even that could be partly predicted, then perhaps the world was not a collection of surprises. Perhaps it had a structure. Thales was not alone in this shift. Other thinkers followed, and they were a strange, bold group. Anaximander imagined the Earth suspended in space, not resting on a pillar or floating on a divine animal. He thought of it, oddly, as something like a cylinder. Anaximenes looked for explanations in air. Pythagoras and his followers saw number and proportion beneath reality. Democritus imagined matter made of tiny indivisible units. Aristotle built an enormous system for nature, motion, elements, animals, politics, logic, and the heavens. They were often wrong, sometimes beautifully wrong. Anaximander's Earth was not a cylinder. Aristotle's physics would eventually fail. Many Greek cosmologies were built on assumptions we no longer share. But this is not a failure of the story. It is the story. Science does not begin with correct answers. It begins when people agree that better questions are possible. Could this event have a natural cause? Could the same cause happen again? Could we describe it without invoking a personality behind it? Could we test one explanation against another? Once those questions enter a culture, they are difficult to remove. A myth can answer what an event means. A natural explanation asks how it happens. Both can comfort, but only one can be adjusted when the next observation does not fit. That flexibility was new and powerful. Think about the emotional effect of it. A comet appears. In the old frame, it may be a warning, a death sign, a message. The question becomes, who is angry? What must be done? In the new frame, the comet may still be frightening, but another question becomes possible. Has this happened before? Did anyone write it down? Does it return? Where was it last night? Where will it be tomorrow? The fear does not vanish. It changes shape. And this is one of the quiet turning points in human history. The mind begins to move from interpretation toward investigation. Not all at once, not evenly, not everywhere, but enough. The stars remained bright. The planets kept wandering. Eclipses still stopped people in their tracks. Only now, beneath the wonder, another thought had appeared. Maybe this can be understood. And if it can be understood, perhaps it can be calculated. Several centuries after Thales, the sky had become a mathematical problem. That is a very strange sentence when you think about it. The same sky that had once held dragons, wolves, gods, ancestors, omens, hunters, and sacred animals was now also holding angles, tables, circles, and numerical predictions. The mythic sky did not simply disappear. People still told the old stories. They still named planets after gods. Astrologers still looked for meaning in celestial movement. But beside that older sky, another one had been growing. A measured sky. Greek astronomers built geometric models. Babylonian astronomers preserved long records of planetary motion. Egyptian calendars, Greek mathematics, Mesopotamian observations, and later Islamic scholarship all became part of the same long inheritance. No single culture owned the result. Astronomy was already a conversation across languages. One of the most important figures in that conversation worked in Alexandria in the 2nd century AD, Claudius Ptolemy. Ptolemy did not begin from nothing. That is important. He gathered, organized, corrected, and extended work that had been accumulating for centuries. He drew on Greek geometry, the star catalogue associated with Hipparchus, and the deep observational tradition that came from Mesopotamia. Then he gave the whole structure a form that could travel. His great astronomical work was known in Greek as the mathematical syntaxis, later admired as the Great Compilation. Through Arabic translation, and then Latin transmission, it became known as the Almagest. For many centuries, the Almagest was one of the central books of astronomy. It was studied in the Greek-speaking world, translated and developed in the Islamic world, then carried into medieval and Renaissance Europe. Its influence lasted until the rise of heliocentric astronomy in the 16th and 17th centuries. Today, we know Ptolemy's universe was not physically correct. Earth is not the centre of the solar system. The planets do not orbit us. The sun does not circle the Earth once a year. But calling the model simply wrong makes the story too easy. Ptolemy's system was not true in the modern sense, but it was useful. It could predict positions in the sky with real skill. It gave astronomers a way to calculate what they would later see. For calendars, planetary tables, and astronomical education, it worked well enough to survive. That phrase, well enough, deserves respect. A model can be physically mistaken and still mathematically powerful. It can describe appearances without revealing the deeper structure beneath them. Anyone who has used a map knows this. A flat subway map is not the actual shape of a city, but it can still get you home. Ptolemy's model was something like that, a map of appearances. The problem it had to solve was difficult. If you watch the planets over many nights, they do not behave like ordinary stars. The fixed stars rise and set together, maintaining their patterns. Mars, Jupiter, Saturn, Venus, and Mercury wander. Usually they move in one direction against the background stars. Then, for a time, they slow down, stop, reverse, move backward, stop again, continue forward. This backward-looking motion is called retrograde motion. You can see it without a telescope if you have patience and a clear sky. Mars is especially noticeable. Over weeks it traces a loop against the constellations, as if it changed its mind in the middle of the journey. From a heliocentric point of view, retrograde motion is not mysterious. Earth and the other planets are all moving around the Sun at different speeds. Sometimes Earth overtakes another planet, and from our moving viewpoint that planet seems to drift backward for a while. But Ptolemy did not begin from that viewpoint. He began, as most educated people of his world did, with Earth at the centre, so he needed geometry capable of saving the appearances. His solution used circular motions. A planet moved on a small circle called an epicycle. The centre of that epicycle moved along a larger circle called the deferent. Ptolemy also used other refinements, including eccentric circles and the equant, to make the timing work more accurately. To modern ears, this can sound absurdly complicated. Little circles riding on bigger circles, adjustments inside adjustments. But the aim was serious. The model was trying to turn a wandering sky into a calculable one, and in many cases it succeeded. An astronomer could use the system to estimate where a planet would appear. The model was not a photograph of the solar system. It was a mathematical instrument, a way of translating sky movement into numbers. That is why Ptolemy lasted. Not because everyone was foolish, not because nobody noticed difficulties, not because ancient astronomers lacked intelligence. He lasted because his model gave results. This is one of the most useful lessons in the history of science. Bad assumptions do not always fail immediately. Sometimes they produce good predictions for a long time. They become woven into textbooks, institutions, calendars, religious imagination, navigation and teaching. They become part of the furniture of thought. And once an idea becomes furniture, people stop seeing it as an idea. They see it as the room itself. That was the strength of the Earth-centered universe. It matched common experience. You stand still, the sky moves, the ground feels stable, the sun rises and sets, the stars circle overhead. Nothing in ordinary life tells you that you are on a rotating sphere travelling around a star. The senses vote for geocentrism every morning. So the old model had two kinds of support. It fit everyday perception, and it could be made to fit mathematical prediction. That is a powerful combination. Still, every model has edges. Over time, astronomers had to keep adjusting tables and refining methods. The Ptolemaic tradition was not frozen. Scholars in the Islamic world criticized it, improved it, and sometimes searched for alternatives. Astronomers built observatories, recalculated parameters, and noticed small mismatches between inherited theory and fresh observation. The pressure did not explode immediately. It gathered slowly. This is another way science often changes, not through one dramatic argument, but through many small irritations, a number that does not quite match, a prediction that needs correction, a model that works, but only after special handling, a student who asks why the machinery has become so heavy. For centuries the weight could be carried. Then, eventually, someone begins to wonder whether the problem is not in the newest calculation, but in the first assumption. Maybe Earth is not the still point. That thought had appeared before Copernicus. Aristarchus of Samos, many centuries earlier, had proposed that Earth moved around the Sun. But the idea did not become dominant. It lacked the cultural, mathematical and observational support needed to dislodge the older system. Then, in 1543, Copernicus published on the revolutions of the heavenly spheres. He placed the Sun near the centre and made Earth one planet among others. This did not instantly solve everything. Copernicus still used circles. He still needed technical devices to match the sky. His system was elegant in some ways and awkward in others, but it changed the starting point. That was enough to unsettle the whole room. A familiar universe began to loosen. If Earth moved, then the ground beneath human certainty was not as still as it felt. If Earth was a planet, then humanity did not occupy the obvious centre of creation. If the apparent motion of the sky came partly from our own motion, then seeing was not the same as understanding. That last lesson is a smus. What looks obvious can be wrong. The sun appears to rise. Really, the Earth turns. The planets appear to wander backward. Really, the observer is moving too. The ground appears motionless. Really, it is carrying us through space at tremendous speed. Astronomy became a training ground in humility. It taught human beings that perception is powerful, but not final. Still, Copernicus alone was not enough. A new model can be proposed on paper. For it to transform the world, it needs evidence that people cannot easily look away from. Mathematics had carried astronomy a long way. Observation had carried it too. But the human eye was still limited. From the ground, with unaided sight, the planets remained bright points. The moon showed markings, but not mountains. Jupiter was a light, not a world. Venus was a star-like glow, not a body with phases. The debate could continue inside diagrams, tables, and philosophical commitments. Then a new kind of eye entered the story. Not an eye made of flesh. Glass would be the next threshold. Not an argument about the sky, but a new way of seeing it. A small tube of wood and glass. Not much to look at first. A lens at one end, another lens at the other. The kind of object you could hold in two hands and mistake for a clever toy. But in 1609, Galileo Galilei lifted something like that toward the sky. He was 45 years old then, teaching mathematics in Padua. He had not invented the telescope. News had reached Italy of Dutch spectacle makers who were placing lenses inside tubes and making distant objects appear closer. Hans Lippershey's name is usually attached to that early invention, though the exact origin is a little more crowded and uncertain than one famous name can carry. Galileo heard about the device and understood the idea quickly. Then he improved it. That part matters. The first spyglasses were weak. Useful, perhaps, for seeing ships before they reached the harbour, or soldiers moving in the distance. Tools for merchants, commanders, sailors, instruments for the horizontal world. Galileo made a stronger one, then another. He polished lenses, adjusted distances, tested the image, refined the tube. His best early versions magnified objects about 20 times. 20 times is modest by modern standards. A backyard telescope today can do far more. But for a human eye that had spent all of history limited to itself 20 times was enough to break the old universe open. The instrument was still small. The shift was not. Galileo pointed it at the moon. For centuries the educated view inherited from Aristotle had placed the heavens in a higher category of existence. Earth was the realm of change, growth, decay, weather, illness, rot. Down here things cracked and aged and fell apart. Up there things were supposed to be different, perfect, smooth, circular, more eternal than earthly matter. The moon, visible to everyone, had always shown markings. Pale regions, darker regions, a face some cultures saw, a rabbit others imagined, a strange mottled surface no one could quite explain. But with the naked eye, those marks remained vague. A pattern, not a landscape. Through the telescope, the moon became physical. Galileo saw light and shadow falling across its surface. He saw the line between lunar day and lunar night, the terminator running over ridges and hollows. Near that boundary, shadows stretched long, the way they do on Earth when the sun is low. That was the clue. A perfectly smooth sphere would not cast shadows like that. A rough surface would, mountains would, valleys would, edges, slopes, depressions, uneven ground. The moon was not a polished heavenly lamp. It had terrain. Galileo drew what he saw. Not perfectly, not by the standards of later astronomy, but carefully enough. His sketches made the moon look less like a symbol and more like a place. That was new. A celestial body had been turned into a world with geography. The psychological force of that is easy to miss now. We have seen lunar photographs, satellite maps, crater names, landing sites, footprints in dust. We already know the moon is a place, but in Galileo's time, even that sentence was disruptive. If the moon had mountains, then the old boundary between earth and sky had weakened. The heavens were not pure in the way people had imagined. At least one object up there looked, in certain ways, like down here. The sky was becoming less symbolic and more material. Then came Jupiter. In January 1610, Galileo turned his telescope toward that bright wandering point. Jupiter had been known since antiquity, one of the visible planets, slow and steady, easy to notice if you watched the night sky with any patience. To the naked eye, it had always been a light. Through Galileo's lens, it became a disk, and beside it, he saw tiny points. At first, he thought they were fixed stars. That would have been reasonable. The telescope was revealing stars his eyes had never been able to see, so why not a few faint ones near Jupiter? But the next night, the little lights had changed position, then again, and again. One vanished behind Jupiter. Another appeared on the opposite side. The points seemed to stay close to the planet, shifting around it in a regular way. Galileo watched for days, then weeks. He recorded the positions night after night. The answer slowly became unavoidable. They were not background stars. They were moons, 4 of them. Io, Europa, Ganymede, and Callisto. Though those names came later, Galileo called them the Medicean stars, partly because science in the 17th century still had patrons, politics, and survival folded into it. Naming a discovery after a powerful family was not only flattering, it was a strategy. But whatever he called them, the fact remained. Something was orbiting Jupiter. That changed the argument. Until then, the Earth had been the only known body with a moon. The moon went around us, and that could be taken as evidence that Earth occupied a special place in the arrangement of things. But here was another centre, a small system within the larger system. Jupiter had companions of its own. The universe no longer had to be organised around a single middle point. At the very least, not everything went around Earth. A little later, Galileo watched Venus. Venus is deceptive. To the naked eye, it is brilliant and simple. The morning star, the evening star, a white point bright enough to dominate the twilight. Through the telescope, it behaved more like the moon. It showed phases. Sometimes Venus appeared nearly full, sometimes half-lit, sometimes a crescent. Its apparent size changed too, growing larger when it was crescent and smaller when it was fuller. This was a serious problem for the old Ptolemaic arrangement. In a strict Earth-centered model where Venus stayed between Earth and the Sun, the full range of phases should not appear the way Galileo saw it. But if Venus moved around the Sun, the pattern made sense. This did not instantly settle every possible model of the cosmos. The history is more complicated than a clean victory scene. There were hybrid systems, including Tycho Brahe's, that could preserve some Earth-centered assumptions while allowing planets to circle the Sun. Still, the damage to the old picture was real. Venus was no longer behaving like a decorative light attached to a perfect celestial machinery. It was a body moving through space, changing its visible face according to geometry. That word matters here. Geometry. Not omen, not mood, not personality. Geometry. The telescope was not only showing new things, it was changing the kind of explanation people needed. Then Galileo looked at the Sun, carefully and dangerously. He and other observers studied it by projection and filtered viewing, though early solar observation was not as safe as it should have been. What appeared on the Sun was not perfection. Dark marks crossed its face, sunspots. They moved from day to day, shifting across the solar disk. Some appeared, changed shape, disappeared. The Sun itself, the great symbol of light and order, had blemishes. It rotated. It changed. The old heavenly perfection was getting hard to defend, and there was one more revelation, quieter but enormous, the Milky Way. For thousands of years, that pale band across the night sky had looked like a luminous cloud, a spilled river, a path of milk, a mark left by gods, animals, heroes, souls, depending on which culture was telling the story. Through the telescope, the haze dissolved into stars. Not one object, not a smooth substance, not a vapour. Stars. So many faint points that the eye, unaided, had blended them into a single glow. That is one of the most important things the telescope taught humanity. Appearance is not the same as reality. Sometimes the world looks smooth only because your instrument is weak. Sometimes a cloud is a crowd. Sometimes simplicity is just distance. Galileo published these observations in 1610 in Sidereus Nuncius, Starry Messenger. The title was well chosen. It did feel like a message, but it was not a message from the stars in the old astrological sense. It was a message carried by an instrument. Glass had become a messenger between human eyes and a universe too fine, too far, and too dim for those eyes alone. The book spread quickly. Some readers were astonished. Some were skeptical. Some resisted, not because they were stupid, but because the claims were not small. If Galileo was right, then a whole architecture of thought had to be revised. Natural philosophy, theology, education, the authority of Aristotle, the confidence of inherited knowledge. A new instrument had placed pressure on an old world view. That happens again and again in human history. A tool extends a sense, and the world changes shape. The telescope extended sight. The microscope would later do something similar in the opposite direction, opening the tiny worlds inside water, blood, tissue, disease. Photography would teach us to freeze a moment. Radio would let us hear invisible waves. Spectroscopy would reveal what stars are made of without touching them. The telescope was one of the first great shocks in that chain. It showed that the human eye was not the measure of the real. For thousands of years we had built stories, calendars, gods, maps and mathematical models, using what the unaided eye could see. That had not been foolish. It had been the only instrument available, but now there was another eye, a wider one, and once the wider eye existed, the old ceiling lifted. The moon became a landscape. Jupiter became a small system. Venus became a geometric argument. The sun became imperfect. The Milky Way became a field of stars. None of these discoveries alone finished the old universe. Together they made it difficult to keep living inside it. The sky had been watched before. It had been named, measured, interpreted, written down, calculated. Now, for the first time, it was being seen beyond the limits of ordinary sight. And that new sight did something strange to us. It made the universe larger, and the human being smaller. There is a quiet pattern in the history of astronomy. Every time our instruments improve, our importance changes shape. Not always downward, not exactly. But the old kind of importance, the kind that comes from being central, unique, surrounded, keeps loosening. The moon was not a perfect lamp. It was a rough world. Jupiter had moons of its own. Venus moved in a way that made more sense around the sun. The sun had spots. The Milky Way was not a single glow, but a crowded depth of stars. Each discovery could be absorbed at first. People are good at absorbing shocks one at a time. A crater here, a moon there, a new calculation, a revised diagram. The mind adjusts. But after enough adjustments, the room you're standing in is no longer the same room. The old picture had placed Earth at the centre, not only physically, but emotionally. The universe turned around our location. The heavens formed a structure above us. The sun rose and set for us. The moon followed its path over our nights. The stars circled as if arranged around the human view. It felt intimate, wrong, but intimate. The newer picture was colder at first glance. Earth became a planet. A very beautiful one, but still a planet. Rock, water, air, weather, life, and one large moon, moving around a star that did not move around us. The sun, in turn, became a star. Not the star. A star. Close to us, and therefore bright. Necessary to us, and therefore sacred in practice, whether or not we use that word, but not central to the whole cosmos. From a distance, it would be one more point. Then came a larger loss of centrality. For a long time, even after the Earth had been moved from the centre, the Milky Way still felt like the universe itself. A vast island of stars, perhaps, but the main structure, the container. There were hazy patches in the sky, of course. Nebulae, faint smudges. Some looked spiral through stronger telescopes. Astronomers debated what they were. Were they clouds of gas inside the Milky Way, or separate star systems much farther away? This was not a small disagreement. It was a question about the size of reality. In 1923, Edwin Hubble used the 100-inch Hooker telescope at Mount Wilson to study the Andromeda Nebula. Inside that faint smudge, he identified a Cepheid variable star. Cepheids matter because their rhythm reveals their brightness. Henrietta Swan Leavitt had discovered that relationship years earlier while studying variable stars. A Cepheid's period, how long it takes to brighten and dim, tells astronomers its true luminosity. Compare that true brightness with how bright it looks from Earth, and you can estimate distance. It is one of the great measuring tools in astronomy. Hubble used it. And the result was astonishing. Andromeda was not inside the Milky Way. It was far beyond it. Today we place it roughly 2.5 million light-years away. The exact number has been refined since Hubble's time, but the meaning has not changed. Andromeda was another galaxy, a huge system of stars outside our own. The Milky Way was not the universe, it was one galaxy, one island among many. That single measurement altered the scale of human thought. Again. Andromeda is visible to the naked eye under dark skies, a soft blur, easy to miss if you do not know where to look. The light from it has been travelling toward us for more than 2 million years. It began its journey before our species existed in its present form, and when it reaches your eye, it is gentle, almost nothing, a faint patch. That is the strange humility of astronomy. The largest things do not always arrive with force. Sometimes they arrive as a smudge. After Andromeda, the count kept expanding. Not 2 galaxies, not 10, not 1,000. The observable universe contains at least hundreds of billions of galaxies, and some estimates place the number much higher, even up to around 2 trillion. Galaxies themselves vary enormously. Some are small dwarf galaxies with millions or billions of stars. Others contain hundreds of billions, even more. Our own Milky Way is only one of them, and around many stars, planets, rocky planets, gas giants, ice worlds, worlds close to their stars, scorched into strange forms, worlds far away, frozen into darkness, worlds orbiting 2 stars, worlds that seem almost impossible until the data says, there they are. The universe did not become larger when we discovered these things. It had always been large. We simply became aware of more of it. That awareness is not easy to hold. We use words like billion and trillion as if they fit comfortably in the mouth. They do not fit comfortably in the mind. 100 is already something you have to count. 1,000 becomes a crowd. 1,000,000 is an abstraction. 1,000,000,000 is usually just a word we repeat because the world requires it. Then astronomy asks us to go further. Billions of stars, billions of galaxies, millions of light years. Space so wide that even light, the fastest thing in the universe, becomes slow when measured against it. No wonder people feel small under the night sky. The feeling is not a mistake. It is the body trying to respond to information the body was not built to contain. Most of our daily lives unfold at human scale. A room, a street, a kitchen table, a familiar road, the distance to a friend's house, the shape of a town. Even a country, for most people, is more idea than lived experience. Then the mind is asked to imagine a galaxy. It struggles. So the feeling becomes emotional instead. Awe, fear, silence, sometimes loneliness. This is one of the deeper changes astronomy brought into modern life. It created a new kind of solitude. Earlier cultures could fear the sky, worship it, read it, bargain with it, place gods inside it. But a vast physical universe, governed by laws and apparently indifferent to human concerns, produces a different mood. Not terror exactly, more like exposure. You stand beneath the stars and understand for a moment that they are not arranged around you. They are not signs placed there for your private story. Most of them will burn whether or not anyone is watching. Galaxies will collide, stars will form and die. Light will travel for ages across emptiness. Your life, next to that, is brief. Very brief. This can sound bleak if we stop there. Many people did stop there. Modern thought has often told the story as a loss. Science removed us from the centre, stripped the sky of meaning, and left us small in a silent universe. There is truth in that feeling, but it is not the whole truth. Getting smaller is not the same as becoming meaningless. A child feels like the centre of a house because for a while, the house turns around them. Food arrives, voices answer, arms lift them. The world is close and personal. Then the child grows and sees the street, the city, the wider life of other people. The discovery can be painful. The house was not the world. But the house did not become worthless. It became located. Something similar happened to humanity. The Earth was not the centre of the universe. That old comfort was wrong. But losing the centre gave us something else. Location. We learned where we are. A planet around a star inside a galaxy among many. Small, yes, but real. specific, findable, and there is a strange dignity in that. The old universe made us important by placing us in the middle. The new universe asks for a different kind of importance, not centrality, participation. We are matter that learn to look back at matter, atoms arranged in such a way that they can wonder where they are. A temporary species on a small planet, building instruments, naming stars, arguing over models, correcting errors, making maps of spaces we will never personally cross. That matters. It may even be more moving than the older idea. Because in the older picture, meaning was guaranteed by position. We mattered because everything revolved around us. In the newer picture, meaning has to be made under harder conditions. We are not given the centre. We have to build understanding from the edge. That is harder. It is also more honest. And honesty has its own beauty. By the time astronomy had made us smaller, it had also given us tools the old worldview never could have provided. If Earth is a planet, then other planets are places. If the Moon is a world with terrain, then perhaps one day something can land there. If Jupiter has moons, then worlds can circle worlds. If Venus shows phases, then bodies move through space according to geometry. If gravity holds the Moon in orbit, perhaps a machine can be placed into orbit too. Smallness, in other words, was not only a wound, it was preparation. The human being at the centre of creation had nowhere to go. The centre is a fixed position. It is a throne, not a road. But the human being on a planet has a horizon. A small planet can be departed from. A nearby moon can become a destination. A solar system can become a map. That is the turn in the story. The telescope made us smaller, but by making the sky physical, it also made the sky reachable in thought. The heavens were no longer only above us, they were around us. And once the sky became a place, the next question was inevitable. How do we get there? Newton did not need a rocket to change spaceflight. He needed a falling object and a question sharp enough to reach the moon. The Apple story is probably polished by memory. Newton did tell a version of it late in life, but whether an apple actually dropped beside him in exactly the right dramatic way is not the important part. The important part is the thought it opened. Why does an object fall downward? And if the same force pulls an apple toward Earth, could it also be pulling the moon? At first that sounds wrong. The moon does not fall in the ordinary way. It does not crash into the ground. It simply keeps moving across the sky, night after night, as if held in place by some separate celestial rule. Newton's insight was to remove the separation. Maybe the moon is falling. Maybe it has always been falling. It just has enough sideways motion to keep missing the Earth. Imagine throwing a stone from the top of a mountain. It travels forward and drops. Throw it faster, and it lands farther away. Throw it impossibly fast, and the curve of its fall begins to match the curve of the Earth beneath it. It keeps falling, but the ground keeps bending away. That is an orbit, falling without arriving. The idea is almost too elegant. The moon is not pinned to the sky. It is not resting on a crystal sphere. It is in motion, pulled inward and carried sideways, missing us over and over again. Newton published the mathematics behind this in 1687, in the Principia Mathematica. His laws of motion and universal gravitation did not only explain falling objects, they connected falling objects to planets, moons, comets, tides, and eventually trajectories through space. Galileo had shown that the heavens were physical. Newton showed that they obeyed the same rules as everything else. The old division between above and below weakened again. The mathematics that described a pebble falling could also describe Saturn's orbit. Earth and sky belong to one system. That change mattered far beyond astronomy. A universe governed by consistent rules becomes a universe that can be investigated. If a motion has a law, it can be calculated. If it can be calculated, it can be predicted. And if it can be predicted, human beings can prepare for it. The effect showed up almost immediately in the sky. In 1705, Edmund Halley studied earlier reports of comets seen in 1531, 1607, and 1682. The appearances looked too similar to be separate accidents. Using Newton's ideas, he argued that they were the same comet returning roughly every 76 years. He predicted it would come back in 1758. Halley died before he could see it. But the comet returned, close to the predicted time, and it has carried his name ever since. Its next return is expected in 2061. That prediction changed the emotional status of a comet. For centuries, comets had been read as omens: war, plague, disaster, the death of kings. After Halley, a comet could still be beautiful. It could still feel uncanny. But it was also an orbit, a visitor with a schedule. Fear did not disappear, but one part of fear had been converted into calculation, and calculation made a new kind of imagination possible. After Newton, the dream of leaving Earth did not immediately become practical. The technology was not there. There were no modern rockets, no liquid fuels, no guidance computers, no industrial systems capable of building a spacecraft. But the dream had changed shape. It was no longer only a mythic ascent, a ladder to the gods, or a chariot through the heavens. It could now be described as a problem of speed, mass, direction, fuel, and trajectory. In 1865, Jules Verne published From the Earth to the Moon. The method in the novel was impossible: a giant cannon firing a capsule toward the moon. The acceleration would have killed any passengers instantly. But Verne did something that mattered. He treated the journey as a technical problem. He placed the launch in Florida, which was not a random choice. A launch closer to the equator can take advantage of Earth's rotation, and an eastward launch over ocean gives a safer path downrange. Verne did not have modern mission design, but he was thinking in the right direction. He gave the mission 3 travelers. He imagined a capsule. He calculated timing and trajectory with the tools available to him. In the later continuation of the story, the capsule splashes down in the Pacific. Some of the parallels with Apollo are coincidental. Some come from the fact that, once you take physics seriously, the physics begins to narrow the possibilities. Verne did not solve spaceflight. What he did was make it feel engineerable. That is a crucial step. People do not usually build what they cannot first imagine in some workable form. A fantasy can be vague forever. A dream that produces questions becomes different. What speed? What fuel? What angle? What shape? What material? At that point, the dream has become a problem, and problems can be handed from one generation to the next. Konstantin Tsiolkovsky, a Russian school teacher who had read Verne, became one of the people who took that problem seriously. In 1903, he published work that helped lay the mathematical foundation for modern rocketry, including the importance of multi-stage rockets and the relationship between exhaust velocity, fuel, and final speed. Tsiolkovsky later wrote that Earth is the cradle of humanity, but one cannot remain in the cradle forever. The sentence became famous because it holds both tenderness and restlessness. A cradle is not a prison, it is a beginning. Robert Goddard in the United States worked the problem from another direction. In 1926, near Auburn, Massachusetts, he launched the first liquid-fueled rocket. It rose only about 41 feet. By the standards of later rockets, it was almost nothing. By the standards of history, it was a door opening. Werner von Braun also grew up inside the imaginative world of rockets and moon voyages. His story carries a darker weight because of the V2 program in Nazi Germany and the forced labour tied to it. The road to space was not morally clean. It passed through war, ambition, fear, propaganda, brilliance, exploitation, and national competition. That honesty matters. Wonder should not require forgetting the cost. Still, the technical lineage is real. The mathematics of Newton, the dreams of Verne, the equations of Tsiolkovsky, the experiments of Goddard, and the enormous rocket programs of the 20th century gradually turned the moon from a light in the sky into a destination with a flight plan. A 5,000-year chain had formed. Clay tablets, star catalogues, geometrical models, lenses, equations, fiction, fuel tanks, guidance systems, engines. The dream alone was not enough for an engineer, but an engineer rarely begins without some dream already alive in the culture. They travelled together, and when the first object finally left Earth for orbit, it was not grand in appearance. It was not a ship with windows. It was not a person looking back. It was a polished metal sphere carrying a radio pulse. October 4th, 1957. a rocket rose from the steppes of Kazakhstan, carrying something the world had never seen before, a human-made object bound for orbit. At the top was Sputnik 1, a metal sphere about 58 centimeters across, weighing roughly 84 kilograms with 4 long antennae extending from its surface. Inside were batteries, temperature and pressure sensors, and a radio transmitter. The name Sputnik means something like fellow traveller or travelling companion. After 1957, the word became attached to satellites themselves. The R-7 rocket placed it into an elliptical orbit. At its lowest point, Sputnik passed a little more than 200 kilometers above Earth. At its highest, close to 940. It moved at roughly 8 kilometers per second, fast enough to keep falling around the planet instead of falling back onto it. Every 96 minutes or so, it completed one orbit, and it spoke. Beep, beep, beep. The signal was simple enough for amateur radio operators to hear. Around the world, people tuned into a sound that was not coming from a tower, a ship, or a city. It was coming from above the atmosphere, from a small object circling the planet. Scientifically, Sputnik was modest. Historically, it was enormous. It proved that orbit was no longer only an equation. Newton's mechanics, Tsiolkovsky's rocketry, industrial engineering, state power, and Cold War urgency had all converged into one moving point of metal in the sky. For the United States, the launch produced shock. If the Soviet Union could place a satellite in orbit, it could also threaten to deliver weapons across continents. Newspapers, politicians, schools, and households felt the same sudden question. Had America fallen behind? The fear became known as the Sputnik crisis. In 1958, the United States created NASA. Congress also passed the National Defense Education Act, pouring new attention into science, mathematics, and technical education. A small sphere in orbit helped reshape classrooms, laboratories, budgets, and national ambition. But beneath the politics, another shift was happening. For tens of thousands of years, people had watched the sky. They had named it, feared it, measured it, and used it for time and direction. But they had not put anything into it. Now they had. Humanity was no longer only the observer beneath the heavens. It had become, in a small and fragile way, a participant in them. The first participant had no eyes. Sputnik carried no camera. It did not see Earth. It did not feel awe. It only orbited and transmitted. But its orbit made the next thought unavoidable. If we can send an object, one day we can send a person. And if we can send a person, one day that person can look back. That happened quickly. On April 12th, 1961, Yuri Gagarin became the first human to orbit Earth. His Vostok 1 flight lasted about 108 minutes, one circuit of the planet, less than 2 hours, and yet enough to change the definition of human experience. He saw Earth not as ground, not as territory, not as a map, but as a planet. Blue, curved, luminous, suspended in blackness. Then came the photographs. December 24th, 1968. Apollo 8 carried Frank Borman, James Lovell, and William Anders into lunar orbit. They did not land. That would come later. But they became the first humans to circle another world, orbiting the Moon 10 times before returning home. During one of those orbits, as the spacecraft came around from the far side, Earth appeared over the lunar horizon. A blue-white sphere above a grey, battered surface. Small, delicate, half in light, half in shadow. Anders reached for a camera. The photograph became Earthrise. It is difficult to overstate what that image did. People had seen maps of Earth before. They had seen globes. They had seen photographs from low orbit. But Earthrise was different. It placed home inside a wider scene. Not the centre of all things, not the floor beneath our feet, but a bright, vulnerable body seen from the neighbourhood of another world. No borders were visible, no flags, no empires, no arguments, only cloud, ocean, land, light, and the darkness around it. Anders later said that they went to explore the Moon, but discovered Earth. The line has endured because it is true in more than one way. Space exploration did not only expand our view outward, it turned the human gaze back toward home. From Sputnik to Apollo 8, only 11 years had passed. From the first artificial satellite to the first human view of Earth rising over the moon, a single, astonishing decade. A species that had spent thousands of years reading the sky had finally entered it. And once we look back, the story changed again. 4 years after Earthrise, another crew left Earth. December the 7th, 1972. Apollo 17 lifted off from Florida and began the last human journey to the lunar surface of the Apollo era. On the way to the moon, one of the astronauts looked back and took a photograph of Earth. Not a crescent Earth, not a half-lit Earth rising over the lunar horizon. This time the whole planet was illuminated. Blue ocean, white cloud, brown land, a bright curve of Antarctica near the bottom, Africa and the Arabian Peninsula visible through the swirl, no borders, no labels, no names written across it, just the planet. The photograph became known as the Blue Marble, and the name fit. Earth looked round, delicate and strangely holdable, as if the entire world could rest in the palm of a child's hand. That image became one of the most reproduced photographs in history. It entered textbooks, posters, classrooms, environmental campaigns. It became part of how modern people imagine the planet itself. And the reason is simple. Most of us never see the whole. We live inside pieces, a country, a city, a street, a room, a body. A problem that feels enormous because we're standing right next to it. Maps teach us division early. They give each region a border, each border a colour, each colour a name. The United States here, Canada there, Brazil below, Europe separated into small familiar shapes. The lines look permanent because we see them so often. But from space, those lines disappear. What remains is not political, it is physical. Ocean, cloud, weather, desert, forest, ice. None of this was new information. Everyone already knew that borders were human inventions, but knowledge and vision are not the same thing. You can know a fact for years and still feel it for the first time only when you see it. The Blue Marble did that for millions of people. It turned Earth from an idea into an object, not an object in the cold sense, something more intimate than that, a home seen from outside. Astronauts have described this change again and again. Edgar Mitchell, returning from the moon on Apollo 14, looked out and saw Earth, moon, sun, and deep space in one field of awareness. Rusty Schweikart, floating outside Apollo 9 with only a tether between his body and the planet below, described a similar shift. The details differed. The feeling returned. The Earth was not merely where they had come from. It was the shared place. In 1987, the writer Frank White gave this response a name, the overview effect. It is not one simple emotion. It is usually described as a mixture of awe, fragility, unity, and responsibility. First, fragility. From orbit, the atmosphere looks impossibly thin. Not like a ceiling, not like an endless sky. More like a narrow glow around the edge of the world. Everything that lets us breathe, farm, sleep, burn fires, raise children, build cities, and argue about the future is held inside that narrow layer. Second, unity. From the ground, human difference fills the whole view. Languages, flags, borders, arguments, histories, wounds. From above, the scale changes. The divisions do not vanish morally or politically. They still matter on the ground. But they stop looking ultimate. They become local. And Earth becomes primary. Christina Koch described this beautifully from her own experience in orbit. Looking from the space station, she spoke of seeing the thin line of atmosphere and realizing that every person she knew was sustained inside it. From that view, you do not see borders, religious lines, or political boundaries. You see Earth, and you understand that we are more alike than different. That thought can sound sentimental from the ground. From space, it seems to arrive as evidence. Third, meaning. All known life is here. Every forest, every whale, Every desert flower, every crowded train, every sleeping child, every person you have ever missed, loved, misunderstood, or tried to become. Here, not spread casually across the stars, not waiting in abundance just next door. As far as we know, life is gathered on this one blue world, moving through darkness with no visible support. Maybe that is why the overview effect is not always cheerful. We can have grief inside it. Seeing beauty at that scale can make the world feel more precious, but also more vulnerable. William Shatner, after his brief flight to space, famously returned shaken, not triumphant. He had expected wonder. What he felt was closer to sorrow. That response makes sense. To see Earth from outside is to lose a comfortable illusion. The illusion that the world is too large to damage, too stable to change, too divided to share one fate. Space removes that illusion. It does not solve our problems. A photograph cannot end conflict. A view from orbit cannot repair a climate system or heal every human fracture. But it can change the emotional scale of the question. It can remind us that care is not weakness. Care is realism. Most of us will never leave Earth. We will never look back at the planet through a spacecraft window. Our lives will unfold here, on the surface, inside weather, gravity, errands, screens, meals, work, worry, love. But astronauts go far enough to bring back a perspective we cannot reach ourselves. That is part of their work too. They do science, they test vehicles, they operate machines, they collect data, but they also return with a sentence, an image, a changed face, a way of speaking about home that makes the rest of us pause. And sometimes that pause is enough. Not enough to fix everything, but enough to soften something, enough to make the world feel shared again. That is where Artemis enters the story. Not as a perfect program, not as a magic answer, but as the next chapter in the long human effort to look from farther away and then come home with a clearer sense of what matters. Apollo 17 came home in 1972. After that, no one walked on the moon for more than half a century. That is still a strange fact. In 1969, the future looked as if it had already begun. Many people assumed lunar bases would follow. Mars would come soon after. Space would open steadily, decade by decade, like a continent on an old map. History moved differently. The Apollo program ended. Human spaceflight turned mostly toward Earth orbit. Skylab, the Space Shuttle, Mir, the International Space Station. Astronauts learned how to live and work in microgravity. They repaired satellites, grew plants, studied the human body, built laboratories above the atmosphere. But the moon waited. Robotic missions went back. Orbiters mapped it. Landers touched it. Samples were studied. New data arrived. Still, no human footprints joined the Apollo footprints after 1972. Meanwhile, Earth changed almost beyond recognition. The Cold War ended. The internet arrived. Phones became small, glowing worlds in our hands. Earth population grew from about 3.5 billion to more than 8 billion. Climate change moved from distant warning to daily weather, fire, flood, policy, and anxiety. Through all of it, the moon stayed where it had always been. Same grey face, same craters, same silent surface. The Apollo footprints remain there too, preserved in dust where there is no wind, no rain, no weather to erase them. Then came Artemis. In 2017, the United States redirected NASA toward a long-term human return to the moon. In 2019, that effort received its mythic name, Artemis, Apollo's twin sister, goddess of the moon and the wild night. The name matters. Apollo had carried the language of light, music, prophecy, and heroic arrival. Artemis carried something slightly different. Return, continuity, the night itself. A sister following the path of a brother, but not simply repeating him. That distinction is important. Artemis is not Apollo again. Apollo was a race, sharpened by the Cold War, astonishing in speed and risk. Artemis is slower, more international, more infrastructural. Its purpose is not only to arrive, plant a flag, and leave. The stated ambition is to learn how to stay, to build systems, test habitats, work near the lunar South Pole, prepare for Mars and make deep space travel less like a single, heroic event and more like a human capability. That is less dramatic in one sense. In another, it is much bigger. Artemis II became the first crewed flight of that new era. 4 astronauts flew aboard Orion: Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen of the Canadian Space Agency. The mission was not a landing, and it was not a long stay in lunar orbit. That distinction matters. Artemis II was a nearly 10-day journey around the Moon and back, a crewed test flight designed to prove that Orion and the Space Launch System could safely carry people into deep space and return them home. Orion flew out, swept around the Moon on a free return path, and came back to Earth. That sounds simple only because the sentence is short. Inside it were years of engineering, risk, training, navigation, life support, heat shield performance, recovery operations, and thousands of people doing work most of us will never see. The crew launched on April 1st, 2026 from Kennedy Space Center. They travelled farther from Earth than any humans had ever been before, reaching more than 252,000 miles from home. On April 6th, they passed behind the Moon. For about 40 minutes, Earth could not speak to them, and they could not speak to Earth. This old silence returned. No radio, no live image, no human voice crossing the distance. Just 4 people inside a spacecraft named Integrity, moving behind the far side of the Moon. When communication came back, Christina Koch's voice returned over the radio, and what she said mattered. She did not speak only about speed, distance, or hardware. She spoke about choice. We will always choose Earth. We will always choose each other. That is the line I would keep at the heart of this ending. Maybe that is why this mission feels different now. Not only because it goes farther, but because it arrives at a time when so many people are tired of bad news, tired of division, tired of wondering whether we can still do anything together. Then, for a few days, 4 people leave Earth on behalf of everyone else. They look back at the same planet all of us live on. They carry no border with them that can be seen from that distance. And when Koch says we will choose Earth and each other, it sounds less like a slogan and more like a reminder we badly needed. Because after thousands of years of looking up, after all the myths, calculations, telescopes, rockets, wars, rivalries, mistakes, and astonishing machines, that sentence brings the story home. We go to space not because Earth has stopped mattering. We go because it matters more than we knew. Christina Koch's presence on Artemis II carried its own history. She was not there as a symbol only. She was there as an engineer, astronaut, mission specialist, and one of the most experienced people ever to fly in space. In 2019 and 2020, she spent 328 consecutive days aboard the International Space Station, setting the record for the longest single spaceflight by a woman. She also took part in the first all-female spacewalks. Those facts matter because hope becomes stronger when it has a body. Not a vague hope, not a poster. A real person trained through years of technical work, isolation, discipline, failure, repair, repetition, and trust. Koch had already lived through months of orbit. She had seen Earth from above day after day, not as one dramatic glimpse, but as a repeated education. Coastlines sliding past, storm systems turning, city lights appearing on the night side, the thin atmosphere glowing like a boundary between life and everything else. So when she spoke from Artemis II, the words did not feel decorative. They felt earned. And this is where the mission becomes more than a mission. Because Artemis II was full of firsts and near firsts. First crewed Artemis flight. First crewed flight of Orion. First humans to travel to the Moon's neighbourhood since Apollo 17. The first woman, the first person of colour, and the first Canadian to travel around the Moon. Those milestones are easy to list. What they mean is harder and more important. They mean that the story is widening. The first lunar era looked like a very narrow slice of humanity. Brilliant, brave, historically important, yes, but narrow. Artemis does not erase that past. It adds to it. It says the next chapter of exploration can carry more of us in its image. That matters for a simple reason. People need to be able to imagine themselves inside the future. A little girl watching Christina Koch does not need to become an astronaut for the image to matter. A child watching Victor Glover does not need to fly a spacecraft one day. Jeremy Hansen's presence does not matter only to Canadians. Reed Wiseman's command does not matter only to pilots. The point is larger than career inspiration. The point is that human achievement feels different when more kinds of humans are visibly included in it. It becomes less like a monument and more like an invitation. That invitation is one reason space can still create hope, even in a cynical age. Hope is not pretending humanity is noble all the time. We are not. We are reckless, forgetful, easily divided, often cruel to one another and careless with the world that holds us. But we are also the species that learned to predict eclipses, the species that turned clay into records, glass into telescopes, equations into trajectories, radio noise into music from orbit. We built machines precise enough to carry living people around the moon and bring them back through fire. That does not erase our failures. It proves we are not only our failures. This is why Artemis 2 can feel moving in a way that is difficult to explain. Not because a spacecraft fixes the world, it does not. But because it reminds us what coordinated human effort can do when it is pointed toward something larger than one person's fear, one country's mood, one year's argument. Thousands of people across agencies, companies, laboratories, test facilities, launch pads, tracking stations, ships, classrooms and families place their attention on one fragile objective. Send 4 people far from Earth, keep them alive, let them see, let them return. And they did. That is a form of hope, not soft hope, engineered hope, hope with checklists, hope with bolts, hope with sleepless flight controllers and recovery divers, and people testing systems until the ordinary word safe begins to mean something real. At the end of the mission, Orion came back through the atmosphere and splashed down in the Pacific. The crew returned to gravity, to air thick enough to breathe without a machine, to families, to ordinary rooms, to Earth. That return is as important as the departure. Every space story is also a homecoming story. From the first human who looked up at the stars, this was always the hidden direction of the journey. We thought we were studying the sky. We were also learning how to see home. The first look upward gave us fear, then stories, then calendars, then mathematics. It gave us gods and constellations, tablets and star catalogues, telescopes and equations. Eventually it gave us rockets. And when rockets finally carried human beings far enough, they turned around and showed us Earth. The story bent back toward us. That is the quiet truth of this whole journey. The sky was never only about escape. It was about perspective. From the ground, the moon looks like an object above us. From space, Earth becomes the object. From the moon's neighborhood, home becomes small enough to love differently. Maybe that is what Christina Koch's sentence carries. Not a rejection of exploration, but its deepest reason. We will explore. We will build. We will go farther. But ultimately we choose Earth. We choose each other. That is not naivete. It may be the most practical idea in the entire story, because if all known life shares one world, then caring for that world is not a mood, it is survival. And if every future astronaut, scientist, artist, child, farmer, engineer and stranger lives under the same atmosphere, then choosing each other is not sentimentality, it is accuracy. We've travelled a long way in this video, from the first dark skies to the first stories, from constellations to calendars, from clay tablets to Greek geometry, from Galileo's telescope to Newton's gravity, from imagined voyages to rockets, satellites, moon landings, and the long return of Artemis. At each step the sky changed, or rather, our way of seeing it changed. First, it was mystery, then a map, then a clock, then a book of omens, then a mathematical system, then a physical place, and finally, a distance from which we could look back at ourselves. That may be the deepest transformation. Not that humanity reached the moon, but that by reaching toward the moon, humanity saw Earth. The first person who looked up could never have imagined this. They could not have imagined a spacecraft, a camera, a radio signal, a woman named Christina Koch speaking from beyond the moon, or a blue planet small in the window. But they began the gesture. A head tilted upward. A point of light noticed. A question held long enough to become a story. We are still inside that gesture. All of us. Even now, surrounded by screens and schedules, we remain the animal that looks up and tries to understand where it is. Maybe that is why the sky continues to work on us. It does not flatter us. It does not place us at the center. If anything, it does the opposite. It makes us smaller. But somehow, when it makes us smaller, it can also make us kinder. A smaller world is easier to hold in the mind. A fragile world is harder to take for granted. A shared world is harder to abandon. So when this video ends, nothing dramatic has to happen. You do not need to have an epiphany. You do not need to change your life tonight. You do not even need a clear sky. Just remember that above the roof, above the clouds, above the weather and the noise, the same moon is still there. The same stars are still there. And somewhere in our recent past, 4 people travelled around that moon, looked back, and reminded us that home is not a background. It is the point. If this journey stayed with you in some small way, a quiet like or subscription helps this channel continue. But more than that, carry the feeling with you for a moment. Carry the idea that humanity is flawed, yes, but not finished, still learning, still building, still capable of choosing better, still able, after all this time, to look into the dark and bring back light. Looking at the sky was always one of the first ways we learned to look at ourselves. And now, after thousands of years, the lesson has become clearer. We look up, we go out, we look back, and if we are wise, we come home more carefully than we left.